Sorry for the interruption. So here, hybridization concept, it is one of the important concept regarding about here to explain the geometry and the structure of the molecules. So here, VBT cannot explain the structure of methane molecule, ammonia molecule, and H2O molecule like that. But here, the concept of hybridization was proposed by Linus Pauling. This concept is modification of a VBT. So according to VBT,
sir 1 minute, Mogili sir 1 minute. Sir, మిమ్మల్ని హోస్ట్ చేస్తున్నా, చివరికి ఇంకా మీరు ఎండ్ చేస్తాను మీ సెషన్.
ఓకే,
మధ్యలో సెల్లో జాయిన్ అవుతాను.
ఓకే ఓకే సార్,
రైట్ సార్, థ్యాంక్ యూ.
According to VBT, the unpaired electrons orbitals are overlapped to formation of a bonding. If the orbitals are overlapped along their internuclear axis to form a sigma bond. If the orbitals are overlapped, so here parallel overlap are perpendicular to the internuclear axis to formation of pi bond. Here the sigma bond is a strong bond than comparison with pi bond. So already you know about here sigma pp. Here sigma pp is greater than sigma sp is greater than sigma ss is greater than pi pp. So this is a formation of different type of bonds. So here the modified VBT is called as hybridization concept. This hybridization concept is intermixing of two or more atomic orbitals of an central atom to form equal number of same energy. A new set of orbitals are formed. So these orbitals are called as hybridized orbitals. This phenomena is called as hybridization. So here intermixing of atomic orbitals. If it has the postulates of hybridization, the orbitals only one atom can participate in hybridization. The orbitals of different atoms cannot participate in hybridization. Suppose here sulfur hexafluoride or methane. Suppose for methane, so here for methane, the central atom is a carbon. The central atom is carbon. So here the carbon orbitals only participate in hybridization. So which one of the orbitals are involved in hybridization? That orbitals are empty orbital or unpaired electron orbital or fully filled orbitals. So whatever may be, so any orbital can participate in a hybridization. So the energies of orbitals participating in hybridization must almost equal. So same energy of atomic orbitals are involved in the hybridization. All the valency orbitals may or may not take part in hybridization. The number of orbitals mixed and the number of hybrid orbitals are formed. So the hybrid orbitals have same energy but differ in orientation. The hybrid orbitals are symmetrically arranged around the nucleus so that the between them is less. So here hybridized orbitals. So hybridized orbitals follow Hund's rule and Pauli exclusion principles. So these are very, very important. So here Hund's rule and Pauli exclusion principle for the filling of hybridized orbital. So hybrid orbitals always form a stronger sigma bonds than pure atomic orbitals. So here hybridized orbitals are a stronger sigma bond than pure atomic orbitals. So here hybridized orbitals cannot form here pi bonds. So here pi bonds cannot form. Only sigma bonds are formed. So this is regarding about here hybridization concept. So here types of hybridization. The hybridization of orbital classified. So following types: Sp hybridization, Sp2, Sp3, Sp3d, Sp3 D2 and Sp3 D2 Hybridization. So here this is a most important. So all this hybridization, if you know, so the hybridization of the molecule, the central atom, to find the geometry and bond angles and bond length we can measure. So what is meant by here Sp hybridization? Equal energy of s orbital and one p orbital of an atom intermixing of to form a two Sp hybridized orbitals are formed. So it is called as Sp hybridization. So one s orbital, one p orbital to form two Sp hybridized orbital. So this is a s orbital is a spherical nature, p orbital is a dumbbell shape. So when the combination of these two orbitals, so there are two intermixing of two orbitals to get two hybridized orbital. So this is a one Sp hybridized orbital. This is another Sp hybridized orbital. These two Sp hybridized orbitals is arranged a linear shape. So this is a linear shape. So they are asking about here how much S character and P character present in Sp hybridized orbital. So one s orbital, one p orbital is involved in Sp hybridization. Therefore, in Sp hybridization, S character is 50% and P character is also 50%. So these two orbitals are linear fashion. Therefore, the angle between two Sp hybridized orbital is 180 degrees. Therefore, it is a linear shape. The best example is beryllium difluoride and acetylene. So these are best examples for Sp hybridization. Here, beryllium chloride. You see here, beryllium electronic configuration is 2s2. Sir, 1s2, 2s2. This is a valency shell. So valency shell has 2 electrons. So here, these 2 electrons are paired, but the beryllium is bonded with 2 chlorines. It has required 2 electrons. For excited state, so 1 electron shifted from s orbital to p orbital. So these 2 orbital, one s orbital, one p orbital, intermixing to form a new set of hybridized orbital. So these hybridized orbitals are called as Sp hybridized orbital. So this is a Sp hybridized orbital. So the Sp hybridized orbital, so each orbital has 1 unpaired electron. This sp hybridized orbital is overlapped with so chlorine pz orbital to formation of, so what type of bond here, sir? Sigma spp bond. So here this is a overlapping space. The overlapping space is nothing but sigma spp bond. Here also sigma spp bond. So they are arranged in so linear geometry. This is for sp hybridization. Now here acetylene, here also sp hybridization. So these unpaired electrons. So here how many unpaired electrons are there here? 4 unpaired electrons, 1 s orbital, 3 p orbitals. So 1 s orbital, 1 p orbital, they are formed sp hybridization. Remaining p electrons are involved in pi bond formation. Okay. So here these sp hybridized orbitals of carbon, this is a one carbon, this is another carbon. So sp hybridized orbitals of carbon, this is sp hybridized orbital of carbon. They are overlapped. So linear overlap to form sigma bond. Sigma sp sp bond. Here one more sp hybridized orbital is overlapped with hydrogen s orbital to formation of sigma sp s bond. So here, how many sigma bonds are there here? 3 sigma bonds, 1 sigma sp sp and 2 sigma sp s bonds. And the remaining 2 p orbitals of 2 carbon atoms. So here py py, so py py, they are overlapped to formation of a pi bond, that is nothing but pi py py. Here one more orbital pz orbital. So this is pz orbital and pz orbital. They are perpendicular to the x-axis. So they are also formed a pi bond. So that is pi pz pz. So between 2 carbons, 1 sigma bond is a cylindrical nature, and the remaining 2 pi bonds, they are abound below the so sigma bonds. So this is regarding about here so acetylene molecule. Sp2 hybridization, 1 s orbital and 2 p orbitals of an atom intermixed and to form a 3 sp hybridized orbitals are formed. It is called as sp2 hybridization. Here this is s orbital, these 2 are p orbital. Total number of orbitals are 3. They are intermixing. So 2 sets of orbitals, 1 s orbital, 2 p orbital, they are intermixing to formation of 3 hybridized orbitals. So these 3 hybridized orbitals are arranged in a trigonal planar geometry. So these 3 sp2 hybridized orbitals arranged a trigonal planar geometry. In sp2 hybridization, what is the S character here? 33.3% and P character is 66.7%. So these hybridized orbitals are directed at angle of 120 degrees with respect to each other and trigonal planar shape. So this is regarding about here sp2 hybridization. The best example is boron trichloride and this is C2. So here C2H4. It is not a C2H2. So next one here, boron trichloride. So this is a sp2 hybridization. So trigonal, planar. So here the bond angle is 120 degrees. Here this is a Sp2 hybridization, ethylene molecule or ethene molecule. Here in ethene molecule, sigma sp2 bond is formed. So here sigma sp2. So these two sp2 hybridized orbitals are overlapped with hydrogen s orbitals. Here also hydrogen s orbital. They are sigma sp2 s bonds. Next one, the unpaired electrons at present in pz orbital, they are partial overlap or lateral overlap to the internuclear axis. So they are formed a pi bond. So this is pi pz. So in ethene molecule, both carbon atoms are sp2 hybridization. One of the sp2 hybrid orbitals overlap with sp2 hybrid orbitals of other carbon atom to form a sigma sp2 bond. The remaining sp2 hybrid orbitals of two carbon atoms overlap with s orbital of hydrogen atom to form 4 sigma sp2s bonds. So here the unhybridized pz orbitals of two atoms overlap laterally to form 1 pi pp bonds. So that is pi pz. The sum of 1 sigma bond and 1 pi bond is called a double bond between two carbon atoms. So this is sp3 hybridization, 1 s orbital and 3 p orbital. They are intermixing to formation of 4 sp3 hybridized orbitals. So each one sp3 hybridized orbital. For s character is 45%, p character is 75%. S character is 25%, p character is 75%. So the best example for the molecule, so whenever it is, if it is sp3 hybridization, so tetrahedral shape, bond angle is 109 degree 28 minutes. So this is regarding about sp3 hybridization. Best example is methane. This is a carbon. So here 4 sp3 hybridized orbital. So each one sp3 hybridized orbital have an unpaired electron. It is overlapped with hydrogen s orbital. Next one, Sp3D hybridization. It is the one of the important. So equal energy of 1 s orbital, 3 p orbitals and 1 d orbitals are intermixed to get 5 Sp3D hybridized orbitals are formed. These 5 hybridized orbitals point towards the corners of trigonal bipyramidal geometry. Bond angles are 120 degrees and 90 degrees. So these are bond angles. The best example is PCl5. So what is about here? I am asking about one of the question. So the axial bond length for PCl5, axial bond lengths are PCl 216 nanometers or longer than the equatorial bond length. ఈ దీని మీద క్వశ్చన్ అడిగేటటువంటి అవకాశం ఉంటుంది నాన్న. సో axial bond lengths of PCl is greater than, so here equatorial bond length. So what is about here, sir? So these chlorines are equatorial chlorines. So these 3 chlorines are equatorial chlorines. But these 2 chlorines are axial chlorines. So the bond length is 216 nanometers. So, but here the equatorial bond lengths are 204 nanometers. So this is one of the important question regarding about here trigonal phosphorus pentachloride. So phosphorus pentachloride, what type of hybridization? Sp3D hybridization. So whenever Sp3 hybridization, it is a trigonal bipyramidal shape. So in that, bond angle is 120 degrees and another one is 90 degrees. So two bond angles are present in, so what is about here? PCl5. For the equatorial chlorines, bond angle is 120 degrees. Axial chlorines, so bond angle is 90 degrees. So this is regarding about here PCl5. Next one, Sp3 D2 hybridization. So equal energy of one s orbital, 3 p orbital, and 2 d orbitals. So for this is s orbital. Here px, py, pz. Next one here dx square, y square, and dz square. It's a very, very important. Which one the orbitals are involved in Sp3 D2 hybridization? So here, so d orbitals are, what is about here? Different types. What is the d orbital? dxy, dyz, dxz, dx square, y square, and dz square. For these 5 d orbitals, so here Eg orbitals are involved in hybridization. dxy, dyz, dxz, they are maybe involved in pi bonding, but not involved in sigma bonding. Okay. So here only dx square, y square orbital or dz square orbitals are involved in hybridization. If it is Sp3d, so which orbitals are involved in hybridization? Yes, sigma, yes, and 3p orbital, 1 dz square orbital. So in that cases, dz square orbital. For Sp3d2, so dx square, y square, and dz square. These are very, very important. So this is octahedral geometry for Sp3d2 hybridization. So bond angle is 90 degrees. So what is about here S character and P character for this? So here S character 16.6%, P character 50%. Next one D character 33.3%. So this is regarding about here Sp3d2 hybridization. So the geometry of SF6 molecules like this. Now here the most important thing, so molecular orbital theory. So what is meant by here molecular orbital theory? Why should we learn molecular orbital theory? So here some of the molecules characteristic properties cannot explain by using valency bond theory. Now here Hund and Mulliken, they are developed based on their quantum mechanics. They are proposed here molecular orbital theory. So here molecular orbital theory is method for describing the electronic structure of molecules using quantum mechanics. So what's our quantum mechanics? So here according to quantum mechanics, electrons, so here electrons are revolved around the nucleus of an atom. So that is meant for atomic orbital. So the maximum probability to find the electron density in an atom, it is called as orbital. Here also, when the combination of two or more atoms, the total electrons are attracted by all the nucleus in a molecule. The electrons are attracting all the nucleus in a molecule. That is meant for a molecular orbital. Here for atomic orbital, the electrons are attracted only single nucleus. For molecular orbital, the electrons are to attract all the nucleus in the whole molecule. The electrons are influence all the nucleus in a molecule. The special and energetic properties of electrons are described by quantum mechanics as molecular orbitals. Surround two or more atoms in a molecule and contain valency electrons between atoms. So molecular orbital theory was developed by, so who's developed here? Hund and Mulliken, Slater and Jones. So molecular orbital theory was originally called Hund-Mulliken theory. It is so represented as Hund-Mulliken theory. According to molecular orbital theory, the atomic orbitals of the bonded atoms lose their identity. They mix up to form the molecular orbitals. Molecular regarded as a polynuclear structure. The space around the nuclei is distributed into molecular orbitals. So these are silent features regarding about here molecular orbital. Just a brief description regarding about here silent features. It is a very, very important to recall that. So molecular orbital exists around all the nuclei of all the bonded atoms in a molecule. Molecular orbitals are formed by combining atomic orbital of comparable energies. So here, same energy of atomic orbitals are to form a molecular orbital. When a set of atomic orbitals combine to form a molecular orbitals, the number of molecular orbitals equal the number of atomic orbitals. So how many atomic orbitals are involved in the formation of a molecules? So here, same number of molecular orbitals formed. Suppose here, two atomic orbitals are combined to form a molecule. So how many molecular orbitals are formed here? Two molecular orbitals. Two atomic orbitals combine to produce molecular orbitals. One of these possesses a lower energy than energy of atomic orbitals, and the other has energy higher than the energy of atomic orbitals. When the combination of two atomic orbitals to form a new set of molecular orbital, in this one, some of the orbitals goes to lower energy comparatively with atomic orbital. They are bonding orbitals. So which one orbital is gain the energy, more energy comparatively with atomic orbital? They are anti-bonding molecular orbital. So therefore, molecular orbitals energetically, they are classified into two types. So here, lower energy orbitals are called as bonding molecular orbital. So higher energy orbitals are called as anti-bonding molecular orbital. Each molecular orbital can accommodate a maximum 2 electrons with opposite spin. So here, very, very important. Each molecular orbital can orbitals depends upon the shapes of combining atomic orbitals. So the molecular orbitals are arranged in the increasing order of their energies. So these are filled in the same way as the atomic orbitals filled in the case of atoms. So they are also called a Pauli exclusion principle and Hund's principle. So filling of electrons in molecular orbital same as atomic orbitals. It means it is followed Hund's principle and Pauli exclusion principle. So this is regarding about here molecular orbital. So atomic orbitals and molecular orbitals. So there are differences between atomic orbitals and molecular orbitals. So what is about here? Simple differences. It is a very, very important. These exist around the nucleus of a single atom. So I already have told. So here the electrons are revolved around the only one nucleus. So here, this is, suppose we will take here. So here, this is a nucleus. So what is about here? The electron cloud around the only one nucleus. So this is called as, what is about here? Atomic orbital. For this molecular orbital, what we have right here, this is a one nucleus. This is a one nucleus. It is another nucleus. But here, the electron cloud. So what we write here, sir, the electron cloud around the two nucleus. So this is represented as, so here, this is molecular orbital. So the difference between atomic orbitals and molecular orbital. So this is exist around the nucleus of single atom. These exist around all the nucleus of a bonded atoms in a molecule. So here their existence is because of the inherent property of the atom. So these are formed by the combination of atomic orbitals comparable energies. So which of the orbitals have similar energy? They are formed molecular orbitals. Next one, these have simple shapes. So s orbital is a spherical shape, p orbital is dumbbell shape, d orbital is double dumbbell shape, f orbital is like a flower bunch. So these are some shapes of atomic orbital. So the molecular orbital, these have a complex shapes. These have a complex shapes. These are very, very important regarding about here. These have complex shapes. Atomic orbitals are designated as S, P, D, and F. But the molecular orbitals are designated as sigma, pi, delta, or sigma star, pi star, and delta star. So simply written as sigma, pi, delta, they are bonding orbitals. Sigma star, pi star, and delta star, they are anti-bonding molecular orbital. So bonding molecular orbital, anti-bonding molecular orbital. So these are differences between, so here atomic orbitals and, so what is about here? So here, so these are atomic orbitals and molecular orbitals. It is a very, very important theory. This is a linear combination of atomic orbital. So mathematically, a molecular orbital is a linear combination of atomic orbital. It is developed by Hund and Mulliken. So what is about here in this main theme is If A and B both are atoms, the wave function of atom A is psi A, the wave function of atom B is psi B. If we take here the wave function psi AB is equal to CA psi A plus CB psi B. So here CB, CA, they are mixing coefficient values. So when we are taking here, the combination of atomic orbitals, two atoms A and B, whose wave functions are psi A and psi B, the combination of these wave functions are possible as a result of two types of combinations. So if the same sign of atomic orbitals, so here psi A and psi B, so plus and plus, so they are intermixing, so they are overlapping. What is about here, sir? Bonding molecular orbital. If it is psi A and minus psi B, so they are forming anti-bonding molecular orbital. So molecular orbitals are two types. One is bonding molecular orbital, psi molecular orbital, and anti-bonding molecular orbital. So this is taking as I will take one example. So probability of finding an electron in atomic orbital A is equal to psi A square. Probability of finding an electron in atomic orbital B is equal to psi B square. So that is involved in A plus B whole square principle. Total probability of finding electron in two atomic orbitals, psi A square plus psi B square. So here psi square molecular orbital gives the probability of finding electron in the molecular orbital. Psi square MO is equal to psi A square plus psi B square plus 2 psi A psi B. Next one, psi square molecular orbital is greater than psi A square plus psi B square. Nana, so here for the molecular orbital, so this much of electron density is more comparatively with atomic orbital. How much density is more, sir? Ante 2 psi A psi B density is more than comparison with. So here psi A square and psi B square. You see a graph in this. So this is a bonding molecular orbital. So how much? So here this is 2 psi A psi B. Electron density is more comparatively with psi A and psi B square anamata. అంటే ఈ రకంగా మీరు అబ్జర్వ్ చేసినట్లయితే సో హియర్ A plus B whole square principle according to A plus B whole square A square plus B square plus 2 AB. So that is how much electron density is more comparatively with atomic orbital. And it is a very, very important. So here 2 psi A psi B electron density is more comparatively with psi A and psi B. So this is a bonding. Next one, if it is anti-bonding molecular orbital, and anti-bonding molecular orbitals are formed by the subtraction overlap of two atomic orbitals. So addition overlap and bonding and subtraction and anti-bonding. So psi star, this is molecular orbital. So here psi A minus psi B. Anti-bonding molecular orbital is formed when the lobes of atomic orbitals of opposite sign overlap. The magnitude of psi star MO is numerically less than of psi A or psi B. So the electron density is present only on one nuclei. It is negligible in between the two nuclei. So here, this is a psi A, this is psi B. So less electron density comparatively with atomic orbital. How much electron density are less here, sir? Ante minus 2 psi A psi B electron density is less comparatively with. So here psi A square plus B plus psi B square. Ante deentloki kelli ఇంత ఎలక్ట్రాన్ డెన్సిటీ తక్కువ ఉంటుంది అనమాట కంపారిటివ్లీ విత్ సో ఇట్స్ అటామిక్ ఆర్బిటాల్స్. సో దిస్ ఈజ్ ఏ bonding and anti-bonding molecular orbital. So here the presentation of molecular orbital, they are sigma bond, a molecular orbital which formed from the overlap of s orbital any direction, head to head overlap of s and p atomic orbital, head to head overlap of 2p atomic orbital is known as sigma molecular orbitals. So sigma bonding molecular orbitals are formed by the combination of atomic orbitals having the same sign. They represented as sigma s, sigma sp, and sigma. So anti-bonding molecular orbitals sigma star s and sigma star sp and sigma star p. So this is. So which one of the orbitals are not involved in bonding? So they are, what is about here? So that is a non-bonding orbitals. So when the electron cloud is 0, that is called as nodal plane. These are known to you. So this is s orbital, s orbital, they are overlapping here, resultant sigma bonding. Here yes, pz orbital, s orbital, they are also sigma sp. Here p orbital, p orbital, they are also pi, sorry, sigma bonding. Here pi bonding, pi star molecular orbital. So a molecular orbital which result from the lateral overlap to atomic orbitals perpendicular to the internuclear axis is known as a pi molecular orbital. So pi bonding molecular orbitals are formed a lateral overlap of 2p atomic orbitals have same sign. That denoted by pi px and pi py. Depends upon the use of px and py orbitals. Pi bonding electron cloud arranged above and below the plane. So these are all these things can be explained by, so what is about here, sir? VBT. Now here very important thing. So this is a p orbital. So here p orbital, they are intermixing. What is about here? Pi bonding. So same sign is overlapped here. So this is a bonding py orbital or bonding px orbital. So this is plus sign and minus sign. They are overlapped to formation of pi bond. So this is called as so anti-bonding orbital. So here pi star 2px. So if it has a one plane is there, this plane is called as nodal plane. For anti-bonding molecular orbital, we have observed a nodal plane. What is about here? General. So postulates regarding about here molecular orbital theory. So you have learn about here this configuration is a very important. What is about here? This is the most important configuration. So what is about here? If you know this order, calculate any molecule. So here, this is a very important. So what we take, if it is up to 14 electron system, up to 14 electron system, more than 14 electron system. Nana idu gurtu pettukovali, up to 14 electron system, more than 14 electron system. So up to 14 electron system. So here pi 2px and pi 2py, they are less energy comparatively with sigma 2pz. but more than 14 electrons, sigma 2pz is less energy than comparison with by 2p. ఇక్కడ తేడా ఉంటుంది నానా. So here up to 14 electron system, pi 2px is equal to pi 2py less energy comparatively sigma 2pz. Okay. దీని యొక్క ఎనర్జీ అన్నది సిగ్మా 2pz వెరీ 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 ఇంపార్టెంట్. pi 2px is equal to pi 2py. మీరు అబ్జర్వ్ చేసినట్లయితే
సార్ ప్లీజ్ మ్యూట్ చేసుకోమన్నారు సార్.
You see here, this is what is about here now. So this is a first diagram is, so up to 14 electron system. So here up to 14 electron system. It is more than 14 electron system. So here, what is about here? This is for more than 14 electron system. We can this. So up to 14 electron system, we can this. Suppose here, what we take? Suppose hydrogen molecule. So how many electrons are there here? So one hydrogen has 1 electron, 2 hydrogens are 2 electrons. So here total electrons are 2. So presence of 2 electrons. So each one hydrogen has 1 electron. This is a 1 more electron. These 2 electrons are opposite spin. So when the combination of these two s orbitals, so these are entering to the sigma. Which one orbital here? Yes. Sigma, yes. So what is about here? When the electrons are entering to the sigma bonding s orbital, so here bond order is, so here 1/2 number of bonding electrons minus number of anti-bonding electrons. So here 1/2, so bonding electrons are 2 minus anti-bonding electrons are 0. So that is equal 2/2 is equal to 1. So bond order is 1. If it is bond order is 1, so a single bond present between 2 hydrogen atoms. So here for helium molecule, helium 2 exist or not? Helium exist or not? So here when we take helium electronic configuration is, what is about here? 1s2. So 2 electrons are present in s orbital. So this is one helium atom, another helium atom. So how many electrons are there here? Total electrons are, what is about here? 4 electrons. For these 4 electrons, so here first 2 electrons are entering to the bonding and another 2 electrons are entering to the anti-bonding. So you write here helium 2 configuration sigma yes. So here sigma yes 2 and here sigma star yes or 1s. We can write here 1s 2. What is about here? Bond order. So bond order is equal to, so 1/2 number of bonding electrons are 2, anti-bonding electrons are 2. So here, what is about here? This is 2 minus 2 is equal to 0. So 1/2 into 0 is equal to 0. 0. So here it has no bond order. Nana. So here this is a 0. 0 into 1 by 2, 0. So whenever it is bond order is 0, it has no bond between helium 2 molecule. And helium 2 exists or not? Helium 2 is not existed molecule. హీలియం 2 అన్నది ఎగ్జిస్ట్ మాలిక్యూల్ కాదు అని చెప్పడానికి మనం ఈ రకంగా తీసుకుంటున్నాం నాన్న. సో నెక్స్ట్ వన్ హియర్ lithium 2. So what is about here lithium 2? Lithium electronic configuration is, so this is 1s2, 2s1. So here 2 electrons from, what is about here? 1s orbital, 1 electron from 2s orbital. Here 2 lithium atoms, similar to that. Here this is 1 electron. So filling of molecular orbital. For this 4 electrons, 2 electrons are entered into sigma bonding. Here 2 electrons are entering to the sigma star. So here, next one, this 1 electron, this is 1 electron, they are entering to the bonding. And what is about here configuration? Sigma 1s 2, here sigma star 1s2 and sigma 2s2. So here bond order regarding about here this molecule, so 1 by 2, so bonding electrons 2 plus 2, total electrons are 4 minus anti-bonding electrons are 2. So that is equal to 4 minus 2, 2 by 2 is equal to 1. So what is about here? Between lithium, how many bonds are there here? 1 bond. So that is a sigma bond is present. This is for lithium. So next one here, suppose here beryllium. Beryllium 2. So beryllium 2 is existed or not? So here beryllium 2. So beryllium electronic configuration. What Nana? So here 1s2. This is for 2s2. So this is a beryllium. Here also beryllium. Okay, beta. Total number of electrons in beryllium. 1 beryllium is 4 electrons. 2 berylliums are, total electrons are 8. Okay. So this for 8 electrons, you see here 2 electrons in s orbital, here 2 s orbital, also 2 electrons. These 2 beryllium atoms here like this. Okay, beta. So here for these 4 electrons, first 2 electrons are entering to the, so here bonding. So these are anti-bonding. So these 4 electrons, first 2 electrons are entering to the bonding and the remaining 2 electrons are entering to the anti-bonding orbitals. So this is what is about here. So bonding and anti-bonding. So we can write here configuration. So molecular orbital energy configuration. MO of beryllium. So what we write here? This is sigma 1s 2 sigma star 1s 2 sigma, this is 2s 2 sigma star 2s 2. So this is what is about here. Next one, bond order. So bond order is equal to, what's our bond order? For this
0,
bond
sir.
order,
1 by 2.
1 by 2, 4 minus
4 minus 4, sir.
4 is
0,
equal
0, sir.
0. So any bond present between two beryllium atoms?
No, sir.
No, sir.
So here no bond is formed between beryllium atoms according to this. So here if it has any unpaired electrons are present in molecular orbitals, it is exists as a paramagnetic nature. If it has any unpaired electrons for molecular orbitals, so the central are molecular orbitals. So this is what is about here, neighboring orbitals are atomic orbitals. So any unpaired electrons? So here no unpaired electrons. If it has a basic number, they may be paramagnetic. మనకేంటంటే ఈవెన్ నంబరే కాబట్టి మనకేంటంటే ఇవి డయామాగ్నెటిక్ నేచర్ ను ఎగ్జిబిట్ చేస్తుంది నన్ను. Is it okay? Okay. Now here one more we will take. So boron. Boron. So B2. So B2. So boron electronic configuration. So here 1s2, 2s2. What is about here? 2p.
1, sir.
So here 1s2, 2s2, 2p1. So here this is a boron atom. Here also boron atom. So what is about here? S orbital has 2 electrons. 2s orbital has also 2 electrons. So 1 electron present in p orbital. Same like this. Here. Okay now. So here these 4 electrons. First 2 electrons are entering to the bonding and the remaining 2 electrons are entering to the anti-bonding. For these 4 electrons, 2 electrons are entering to the bonding and the remaining 2 electrons are entering to the anti-bonding orbital. Next, for these 2 electrons, you see, no. These 2 electrons are, what is about here? Unpaired electron. So these 2 electrons are entering to the, which one orbital here? So this is pi 2px and pi 2py. Pi 2px and pi 2py. So because here these 2 electrons are not filled in only single orbital, because here these 2 orbitals are same energy. Okay, so they have same energy, therefore each one orbital is filled with 1 electron. So therefore, what is about here? The molecular orbitals. So here sigma 1s2, sigma star, what nana? 1s2, sigma
2s2,
2s2,
sigma
star
2s2,
2s2. This is pi 2px1 is equal pi 2py1. Is it right? Okay. So what is about here? Bond order for this. So here 1 by 2. How many bonding electrons? 6 minus 4. Is it clear? Any doubt?
Yes, sir, clear.
So these are bonding. Here, these 2 pairs are anti-bonding. So here, the bond order is 1. If it is bond order is 1, A single bond is formed between boron and boron. Is it diamagnetic or paramagnetic?
Paramagnetic, sir.
Paramagnetic nature, because here, so unpaired electrons are present. So in this orbitals, so presence of these unpaired electrons, it shows a paramagnetic nature. So this is for boron. What is about here? C2. C2, how many electrons are present in C2?
12.
12. It is more than 14 or less than 14?
Less than 14.
Less than 14, up to 14 electron system. Is it right? So here electronic configuration is, so 1s2, 2s2, 2p2. Here carbon, this is also carbon. So here these are 2 electrons, here also 2 electrons. This is 1 electron, here also 1 electron. For this carbon, so this is 2 electrons, here also 2 electrons, and this is exist as 2 electrons. So filling of electrons. Is it right? So here, this is a configuration regarding about here C2. C2 is nothing but like this. So here the molecular configuration is sigma 1s2, sigma star 1s2, sigma.
సార్ 2pz ఫిల్ అయిన తర్వాత పేరింగ్ కాదా సార్ ఇక్కడ?
కాదు నాన్న, ఎందుకంటే ఇప్పుడు చూడండి బిడ్డ, సో దీస్ ఆర్ లోయర్ ఎనర్జీ ఆర్బిటాల్, దిస్ ఈస్ ఫర్ హయ్యర్ ఎనర్జీ ఆర్బిటాల్. Okay, whenever if the energy difference is, if the energy is different, so first of all lower energy orbitals are filled with electron, then after higher energy orbital. ఇక్కడ ఈ రెండు సేమ్ ఎనర్జీ ఉన్నాయి కాబట్టి ఒక్కొక్క ఎలక్ట్రాన్ నిండింది ఫస్ట్, తర్వాత పెయిర్ అప్ అవుతాయి. అంతేకాని ఇవి నిండిన తర్వాత ఇందులోకి వెళ్ళదు ఇది నిండక ముందుకు, ఎందుకంటే దట్ ఎనర్జీ ఆఫ్ సిగ్మా 2pgn greater than pi 2px and pi 2py. ఓకే, సో ఇది నిండిన తర్వాత, ఇవి నిండిన తర్వాత ఇందులోకి వెళ్తుంది, ఇది నిండిన తర్వాత ఇందులోకి వెళ్తాయి, ఇది నిండిన తర్వాత ఇందులోకి వెళ్తుంది. దట్ ఈస్ ఎ ఫెనామినా. ఓకే, సిగ్మా స్టార్, దిస్ ఈస్ 2s2, here pi 2px2 pi 2py2. So how many bonding electrons are there here? Bond order 1/2.
8
Bonding
minus 4.
electrons are
8
8,
minus 4.
4. So what is about here? Bond order is
2.
2. So here the bond order is 2 in carbons. So is it para or dia?
Sir, bonding electrons
Dia.
What, Nana?
Sir, bonding electrons 8 unnadu ఒకసారి అది చెప్పరా?
So bonding electrons, you see here. So these are bonding electrons. 2. This is also bonding electrons. Here, these are bonding electrons. Without star, the orbital is meant for bonding. Whenever it is indicated star, that is meant for anti-bonding. Okay? You see, one more example. It is a beautiful example. nitrogen. How many electrons are there? Each one nitrogen is 7. Total number of electrons are
14. 14.
okay. You see, Nana, ఇప్పుడు ఎవరు డౌట్ అడిగారు చూడండి. So here nitrogen electronic configuration is 1s2, 2s2. This is 2p3. Okay, Vidya. So here 1s2, 2s2, 2p3. For this, it is a nitrogen. Here also nitrogen. So these are atomic orbitals. Okay, these are molecular orbitals. So here nitrogen 1s orbital has 2 electrons. 2s orbital has 2 electrons. 2p orbitals are 3 electrons. These 3 are unpaired electrons. So one more nitrogen is there. Similar to that, here 2 s electron, 1s electrons, 2 2s electrons, 3 electrons are present in p orbitals. Okay. So these electrons, so these 2 electrons, these 2 electrons, total 4 electrons. For these 4 electrons, 2 electrons are entering to the sigma bonding, and the remaining 2 electrons are entering to the sigma star 1s. It is for anti-bonding orbital. This is 2s and 2s. For 4 electrons, 2 electrons are entering to the sigma bonding. So remaining 2 electrons are entering to the sigma star anti-bonding orbitals. Okay. So here 3 electrons. So these 3 electrons, totally 4 electrons. For these 6 electrons, these 6 electrons, first 2 electrons are entering to the same energy orbitals. Next one, 2 more electrons are entering to this orbital. Totally 6. For 4 filled in, pi 2px and pi 2py. Remaining 2 electrons are entered into the sigma 2pz. This is a nitrogen configuration. So molecular orbital configuration. This is Nana sigma 1s 2. This bonding and sigma star 1s2, sigma 2s2, sigma star 2s2. Next one, pi 2p x2, pi 2p y2, and sigma 2p z. So this is a molecular orbital configuration. Nana, మీరు అబ్జర్వ్ చేసినట్లయితే, what is about here bond order for this molecule?
3, sir.
3. Nb minus Na is equal to 3. So here 1/2 into 3. ఎట్లా 3 అవుతుంది అంటే, so
10 minus 4, sir.
10 minus 4, sir. 6/2.
10 minus 4. So
4.
that is equal to 3. 6/2 is equal to 3. Between nitrogen atoms, how many
3
bonds are present here? A triple
3 bonds.
bond.
3 bonds.
3 bonds. So the bond order is 3. It is represent the triple bond. Is it para or dia?
Dia. Dia, sir.
Diamagnetic nature. Is it okay, beta? This is for nitrogen. So next one here, if we go to oxygen molecule. How many electrons are present in oxygen molecule?
16.
16. Total number of electrons are 16. ఎందుకంటే each one oxygen 8 కదా నాన్న, 16 electrons. Whenever it is 16 electron, it is more than 14 electron system. We can follow this diagram. Okay. ఇప్పుడు ఈ డయాగ్రామ్ ను ఫాలో కావాలి. ఎప్పుడు మోర్ దాన్ 14 ఎలక్ట్రాన్ సిస్టమ్. అప్పుడు తిరగబడినటువంటి ట్రయాంగిల్ ఉంటుంది ఇక్కడ. ఓకే, ఇక్కడ ట్రయాంగిల్. సో ఇక్కడ తిరగబడిన ట్రయాంగిల్ ఉంటుంది. ఇజ్ ఇట్? గుర్తుపెట్టుకోగలుగుతారు కదా, తిరగబడిన ట్రయాంగిల్.
సార్ ఈవెన్ ఆడ్ స్పీసీస్ తో చెప్పొచ్చు కదా సార్ డైరెక్ట్. ఈవెన్ ఆడ్ నెంబర్స్ తో చెప్పొచ్చు కదా సార్ డైరెక్ట్.
ఈవెన్ ఆడ్ నెంబర్స్ లో మనం చెప్పినట్లయితే ఇప్పుడు బోరాన్ ఉంది, మళ్ళీ సిస్టమ్ మళ్ళీ మారిపోతుంది. ఇప్పుడు సో హియర్ అప్ టు 14 ఎలక్ట్రాన్ సిస్టమ్ వర్క్ దీన్ని యూజ్ చేస్తాను. ఇంకా చెప్తాను, కొన్ని ఎగ్జాంపుల్స్ ఇచ్చుకొని చెప్తాను మీకు. ఓకే, ఇప్పుడు ఆక్సిజన్. వాట్ ఈస్ అబౌట్ హియర్ ఆక్సిజన్ ఎలక్ట్రానిక్ కాన్ఫిగరేషన్? 1s2, 2s2, 2p, what? 4. Is it right? So this is the oxygen. This is oxygen. So s orbital has 2 electrons. 2s orbital has 2 electrons. For p orbitals 4 electrons. ఈ 4 ఎలక్ట్రాన్ లో ఒక్కొక్కటి ఒక్కొక్క ఎలక్ట్రాన్ నిండిన తర్వాత నెక్స్ట్ ఏమవుతున్నాయి? పెయిర్ అప్ అవుతున్నాయి. దిస్ ఈజ్ ఆల్సో సిమిలర్ టు దట్. హియర్ 2 electrons, here 2 electrons. So here this is like this. Okay now. So next one, these 4 electrons, first 2 electrons are entering to the here, remaining 2 electrons are entered in this orbital. So next one, for these 4 electrons, so first 2 electrons entered here, so remaining 2 electrons entered here. For these 4 electrons are one oxygen, 4 electrons are another oxygen. Total number 8 electrons. So for this 8 electrons, first 2 electrons are entered in sigma 2pz. Then, so remaining 4 electrons are entered. This is sigma, sorry, pi 2px and pi 2py. Then after leftover 2 electrons are entered, say pi star 2px and pi star 2py. This is configuration regarding about here oxygen molecule. Ipudu you observe that a configuration for this molecule here O2 molecular configuration sigma 1s2 sigma star 1s2 sigma 2s2 sigma star 2s2. Okay, next one sigma 2pz 2 and pi 2px2 equal to pi 2py2. Then pi star 2px equal, so 1 electron, so pi star 2py1. This is, so here how many sigma, how many bonding electrons and anti-bonding electrons we are calculated bond order. So bond order is equal to 1/2. bonding electrons are 10, anti-bonding electrons are 6. So here the bond order is 2.
2.
So between two oxygen atoms, so here bond order is 2, therefore a double bond formed between two oxygen atoms. So this bond order represents the number of bonds present between atoms. Is it para or dia?
Paramagnetic.
Here two unpaired electrons are present in pi star 2px and pi star 2py. Therefore, it is exist as paramagnetic nature. It is an oxygen atom. Okay, Nana. Sir, oxygen molecule. If it is O2 minus, O2 minus is nothing but if it has one electron is excess.
2p5 అవుతుంది సార్.
No. Okay. So one electron excess, and it means how many electrons are here? 17 kada beta. Ante one oxygen is minus, ante negative, another oxygen is neutral. So here we can write here like this. Okay? అర్థమైందా బిడ్డ? అర్థం కాలే?
అర్థం కాలేదు సార్.
So O2 minus అన్నాను. O2 minus is nothing but here superoxide. O2 minus is, what is about here? This is a superoxide. Superoxide is used for the submarines. Submarines లలో అట్మాస్ఫియర్ ని క్లీన్ చేయడానికి ఉపయోగించేటటువంటి కెమికల్ ఏంటి బిడ్డ అంటే సూపర్ ఆక్సైడ్స్ అన్నమాట. ఇప్పుడు సూపర్ ఆక్సైడ్ అయాన్ యొక్క MOED ని మనం అబ్జర్వ్ చేసినట్లయితే ఎట్లా ఉంటుంది అని చెప్తున్నానంటే, టూ ఆక్సిజన్స్, వన్ ఈస్ O మైనస్ అండ్ అనదర్ వన్ ఈస్ O అనుకున్నట్లయితే, so what is about here? So actually this is 2px1 ఉండే. ఇప్పుడు నేను ఏం చేశాను, ఒక ఎలక్ట్రాన్ ఎక్సెస్ ఉంది కాబట్టి 2py is also 2 electrons. Is it right?
సార్ -2 ఉంటే ఎట్లా యాడ్ చేస్తారు సార్?
అని చెప్తాను, దానికి కూడా వెళ్తాను నేను. ఓకే, సో దిస్ ఈస్ రిగార్డింగ్ అబౌట్ హియర్. ఇక్కడ అర్థమైందని నేను చెప్పింది ఇది
సార్.
సార్
సార్ ఇప్పుడు ఇక్కడ O2 మైనస్ ఉన్నప్పుడు ఒక్క ఓకే ఎందుకు మైనస్ ఉంటుంది సార్? నెక్స్ట్ ఓ కూడా మైనస్ ఉండొచ్చు కదా సార్?
ఏది
O2 మైనస్ ఉంది సార్, O2 కి మైనస్ ఉంది. ఇక్కడ మీరు ఒక ఓక్ మాత్రమే మైనస్ పెట్టారు.
నేను ఇంకా డెప్త్కి వెళ్తే నాన్న, దిస్ ఈస్ O2 minus, it is a superoxide. It is a one type of specific oxide, that is a superoxide. So in that superoxide, so here the oxidation state is -1/2. ఇంకా స్పెసిఫిక్ గా పోతే ఆక్సిజన్ యొక్క ఆక్సిడేషన్ స్టేట్ ఎంత ఉంటది? -1/2. అంటే నేను ఇక్కడ ఒక ఆక్సిజన్ కు -1/2, ఇంకొక ఆక్సిజన్ కు -1/2, నేను 1/2 ఎలక్ట్రాన్ ని చూపెట్టడానికి వీల్లేదు కాబట్టి, సో ఐ విల్ రైట్ హియర్ వన్ ఆక్సిజన్ హ్యాస్ ఎ నెగిటివ్ సైన్. ఓకే, వన్ ఆక్సిజన్ ఆటమ్ ఇస్ న్యూట్రల్ ఆటమ్. నేను ఇట్లా చూపించాను. ఇస్ ఇట్ రైట్? ఇప్పుడు సూపర్ ఆక్సైడ్ లో ఆక్సిజన్ యొక్క ఆక్సిడేషన్ స్టేట్ ను ఫైండ్ అవుట్ చేయమంటే ఎంత అని చెప్తావు చెప్పు? -12. పెరాక్సైడ్ లో ఆక్సిజన్ యొక్క ఆక్సిడేషన్ స్టేట్
-2.
-1. ఆక్సైడ్ లో ఆక్సిడేషన్ స్టేట్
-2.
-2. -2 ఆక్సైడ్లలో, పెరాక్సైడ్లలో -1, సూపర్ ఆక్సైడ్లలో -1/2. గుర్తుపెట్టుకోండి. ఓకే, దిస్ ఈజ్ ఎ సూపర్ ఆక్సైడ్ అయాన్. నేను ఈ సూపర్ ఆక్సైడ్ లో ఒక ఆక్సిజన్ కి మైనస్ ఇస్తున్నాను, దట్ ఈస్ -1, రిమైనింగ్ ఆక్సిజన్ సింపుల్. ఓకే, ఇప్పుడు నాకు ఎలక్ట్రాన్ ఏమవుతుంది ఇందులో, ఇక్కడ వరకు కామన్. ఇప్పుడు 5 + 4 9 ఎలక్ట్రాన్స్. ఫర్ 9 ఎలక్ట్రాన్స్ 6 ఎలక్ట్రాన్స్ ఇక్కడికి వెళ్ళాయి. సో రిమైనింగ్ 3 ఎలక్ట్రాన్స్ ఇక్కడ పెయిరప్ అవుతుంది. మరి అలాంటప్పుడు ఈ రకంగా పెయిరప్ అయినట్లయితే వాట్ ఈస్ ద బాండ్ ఆర్డర్ ఫర్ సూపర్ ఆక్సైడ్ అయాన్?
1.5, sir.
So 1.5. Is it right? Is it para or dia? Any doubt, Nana? Bond order is equal to 1/2 into number of bonding 10, sir. Minus
7.
7, sir. 7.
Para, sir.
So that is 3/2 is equal to 1.5. Is it para or dia?
Para, sir. Unpaired
Para.
electrons present, sir.
Paramagnetic nature. Why it is paramagnetic nature?
Presence of unpaired electrons.
Presence of unpaired electrons. Is it right? Okay, accept chestara? Okay.
Yes, sir.
Let's take so here one more species is there. This is O2 -2. O2 -2, this is peroxide. It is called as peroxide. Peroxide is nothing but how many electrons?
18, sir.
18 electrons. 18 electrons. Is it right, Nana?
Sir, superoxide की peroxide की difference ఏంటి, sir? Charge difference ఏనా, sir? Superoxide की peroxide की difference ఏంటి, sir?
Based on their oxidation state.
Okay.
Okay, based on their oxidation state. So here ఇంకా నేను మీకు ఆల్కలీ మెటల్ లో మీకు అంటే అది ఈ మెయిన్ గ్రూప్ ఎలిమెంట్స్ చెప్పినప్పుడు మీకు చెప్పి ఉండాలి ఏంటంటే ఆల్కలీ మెటల్స్ ఉన్నాయి కదా, లిథియం, సోడియం, పొటాషియం, రుబీడియం, సీసియం, ఫ్రాన్షియం. Francium is radioactive, that is different issue. All the elements, they are formed oxides. No. Lithium, sodium, potassium, rubidium, cesium, they are formed oxides. Okay? అర్థమవుతుందా?
Okay, sir.
All the alkali metals combined with oxygen to forms their oxides. The formula of the oxides is M2O. What is the formula of oxides? M2O. But here sodium to cesium. Sodium to cesium. They are formed peroxides. M2O2. Nana. Sodium is formed peroxide, potassium is formed peroxide, cesium is formed peroxides. Okay. But lithium cannot form peroxides. Next one, potassium, rubidium and cesium, they are formed superoxides. MO2. MO2. ఏంటంటే size of the metal ion is increases, the association capability of oxygens are increased. Okay, so they are formed. What is about here? Superoxides. And ikkada lithium, sodium, they are not formed superoxides. అంటే ఇప్పుడు cesium అన్నది ఎన్ని రకాల ఆక్సైడ్స్ ని ఏర్పరుస్తుంది?
3 types.
3 types.
3 types.
Potassium 3 types. But sodium
Just two types.
2 types. Lithium
Only one type.
1 type. Lithium cannot form superoxides and peroxides due to the small size. Okay, and ఇప్పుడు పొటాషియం సైజ్ పెద్దగా ఉంటుంది కాబట్టి నంబర్ ఆఫ్ ఆక్సిజన్స్ అసోసియేట్ అయ్యే అవకాశం ఎక్కువగా ఉంటుంది. ఓకేనా? సో దట్ ఈస్ how many electrons are there here? 18 electrons. For this is oxygen O minus. Here also oxygen O minus. Okay, 2 minus charges ఉన్నాయి కాబట్టి నేను ఈక్వల్ గా డిస్ట్రిబ్యూట్ చేస్తున్నాను. ఇదొక ఎక్సెస్ ఎలక్ట్రాన్ ఉంటుంది, ఇదొక ఎక్సెస్ ఎలక్ట్రాన్ ఉంటుంది. అంటే ఆక్సిజన్ ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ ఏంటి బిడ్డ? 1s2 2s2 2p4. కానీ ఒక ఎలక్ట్రాన్ యాడ్ అయింది కాబట్టి అప్పుడు ఏమవుతుంది? 2p5 అవుతుంది. ఇస్ ఇట్ రైట్? ఎస్ ఆర్ నో?
Yes, sir.
Okay, so here these are similar, but here how many electrons are there here? For O minus in pz orbital, p orbital 5. Here p orbital 5. Total electrons are 10. So first 2 electrons are entering here. So remaining 4 electrons are entering to the here, and next leftover 4 electrons are entered pi star 2px and pi star 2py. It means like this. Okay, so what is about here bond order?
One, sir.
So bond order is 1. 10 minus 8 is equal 1. So between oxygen,
Single
so
bond.
what type of bond here, sir? A single bond. So in peroxide, మనం హైడ్రోజన్ పెరాక్సైడ్ రాస్తే ఏం రాస్తావు బిడ్డ?
H2O2, sir.
H bond O bond.
ఓకే, ఓపెన్ బుక్ స్ట్రక్చర్ అని రాస్తారా రాయరా?
Yes, sir.
హైడ్రోజన్ పెరాక్సైడ్ స్ట్రక్చర్ ఏంట్రా? ఓపెన్ బుక్ స్ట్రక్చర్. సో ఆక్సిజన్ సింగిల్ బాండ్ ఆర్ డబుల్ బాండ్?
Single bond, sir.
So is it para or dia?
Diamagnetic.
So it is a diamagnetic nature. Sorry. Dia. So here, how many electrons are present here? Total number of electrons?
18.
18. If it is taking as F2 molecule, how many electrons are present? F2 molecule?
18.
18. So it is similar to hydrogen peroxide ion?
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
Yes or no?
Yes, sir.
Yes. So here O2 minus is similar to F2. మనకు అడుగుతుంటాడు అన్నమాట. So given the following species have same bond order, so same number of electrons, so are isoelectronic species, ఇట్లా అడుగుతుంటాడు అన్నమాట. సో మనం ఏంటంటే నంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ను ఈ రకంగా ఫైండ్ అవుట్ చేస్తున్నాం. ఇస్ ఇట్ ఓకే? సో నెక్స్ట్ వన్ హియర్. CO. What is about CO?
Carbon monoxide.
Carbon monoxide. Carbon monoxide. Carbon monoxide. How many electrons?
14.
14.
14
Bond order 3.
So we can follow which one? First one or second one?
First one, sir.
First one. Up to 14 electron system. Okay. This is carbon. You observe that. This is nitrogen. Carbon electronic configuration is 1s2, 2s2, 2p2. Okay, beta. For nitrogen,
Sir, oxygen.
sorry. Oxygen. So oxygen 1s2, 2s2. This is
Sir, similar to N2 orbital.
yeah. Okay. So this is oxygen. This is for carbon. For filling of electrons here. Two plus 4. How many electrons? 6. So here bond order is what, Nana?
10 minus 4, sir.
Minus 4 is equal
6/2.
6/2 is equal
3,
3.
sir.
So it is similar to what, sir?
N2, sir.
Isoelectronic with
N2.
N2. Okay. ఈ రకంగా మనం ఫైండ్ అవుట్ చేయవలసి ఉంటుంది. ఓకే. ఇప్పుడు సపోజ్ నేను O2 2+ అని రాశాను బిడ్డ.
Isoelectric, sir.
O2 2+. How many electrons?
14, sir.
14. It is similar to
N2.
N2. Is it okay?
Okay, sir.
Yes, sir.
Suppose they are asking about here NO. Nitric oxide. How many electrons?
15.
15. It is more than 14 or? Up
More
to
than 14, sir. More
We
than
can
14.
follow this.
Second
Okay.
one.
So nitrogen here, oxygen. So nitrogen, this is 2 electrons here, 2 electrons, for 3 electrons here. For oxygen, 2 electrons here, 2 electrons. Next one here, this is say 4 electrons. So filling of electrons. So how many electrons are there here? 3 plus 4, 7 electrons. For 7 electrons, 2 electrons are entered here. So 2 electrons are entered, again paired. So 1 electron present in pi star. So what is about bond order? So 1/2, this is 10
10
minus
5, sir.
5, that is equal to
5/2. 2.5, sir.
2.5, sir.
Paramagnetic.
2.5. So is it para or dia?
Para.
Paramagnetic, sir.
Paramagnetic nature. So bond order is 2.5. సో ఈ రకంగా మనం ఏంటంటే సో ఫైండ్ అవుట్ చేయవలసినటువంటి అవసరం ఉంటుంది నాన్న. ఇస్ ఇట్ ఓకే? సో హియర్
సార్ ఒకసారి హెచ్ఎఫ్ మాలిక్యూల్ ఎక్స్ప్లెయిన్ చేయరా?
You see here. సో ఇవన్నీ కూడా మీకు ఇంతకుముందు చెప్పిన డిస్కస్ చేసినటువంటి మాలిక్యూల్స్. సో నెక్స్ట్ వన్ హియర్, దిస్ ఈజ్ ఎ సూపర్ ఆక్సైడ్ O2 minus. So here, so this is for peroxide ion. Carbon monoxide, like this. Nitric oxide. So here cyanide, N2. So here this is HF molecule. You see here, for this HF molecule, no. So hydrogen atom, next one fluorine atoms. So this is a fluorine, this is for hydrogen. The hydrogen atom, which one orbital here? 1s orbital. The electrons are present in 1s orbital. Next one, this 1s orbital is overlapped with, so unpaired electrons present in 2pxr, 2py, 2pz. So whatever may be, so that orbital is overlapped with hydrogen s orbital. So that is a sigma bonding. So here sigma bonding. So this is 2s orbital, it is a non-bonding electrons. So this is a non-bonding electrons. So these are a non-bonding electrons. You see, these electrons. So here sigma bonding. So 2 electrons, this is a non-bonding electron, these are non-bonding electrons. So if it has in HF molecule, the bond order so here, this is a HF molecule. The 2px, 2py orbitals of fluorine are suitable for pi bonding molecular orbital. Since there are no orbitals of same symmetry in hydrogen atom, these remains a non-bonding and designated as, what is about here, pi non-bonding orbitals. So this is regarding about here. So hybridization concept and molecular orbital theory. So some of the examples are there. So we can discussed in previous classes. So these are some of the examples are discussed. Okay. నానా మీకు నేను ఈ స్లైడ్స్ అన్ని కూడా మీకు నేను షేర్ చేస్తాను. ఒకసారి
లేకుంటే నాకు పెట్టండి, నేను పీడిఎఫ్ కన్వర్ట్ చేసి పంపిస్తాను.
ఓకే సార్.
సార్ కంప్లీటా? థ్యాంక్ యూ సార్.
ఓకే సార్.
చాలా సేపు తీసుకున్నారు. నా నెక్స్ట్ క్లాస్ ఏం లేదు, ఇంకా 8:30కి ఎగ్జామ్. ఇంకా ఈరోజు ప్లాన్ ఎట్లా సార్ది ఎక్స్టెండ్ అయింది కదా.
ఓకే సార్, మీరు క్లోజ్ చేస్తారా సార్?
మీరే ఎండ్ చేసేయండి, మీరే హోస్ట్ ఇప్పుడు.
ఓకే ఓకే.
మీరు 2 కొట్టేస్తే 2 లైవ్ కూడా అయిపోతుంది.
ఓకే నాన్న, థ్యాంక్ యూ.
థ్యాంక్ యూ సార్, చాలా సేపు తీసుకున్నారు. ఓకే సార్.